This is the second video for the chain rule, and you'll notice I'm starting at number 5. The last video I did 4 problems, and then I gave you the background of the chain rule. This video is just strictly let's practice sample problems, and I'm going to go from 5 all the way to 20. So I'm going to do some on the left, and then you can try it on the right. You can stop the video and try it yourself, and then check what I say, but I'm not going to stop, okay? So here I have number 5. I have y equals e to the x squared. When you have exponential, remember, when you do the chain rule, is you have to take the derivative of the outside, and the outside in this case is going to be an exponential function, okay? The inside in this case is going to be the exponent, which is x squared. So when I do the derivative, y prime, I'm going to take the derivative of the outside, and since it's an exponential function, we all know if y equals e to the x, y prime is the same thing. So I'm just going to call it e to the u if you want, or e to the x in this case, so I'm just going to rewrite it. So that's what the derivative of that function is, times the derivative of the inside, which is the power rule, which is 2x. So you'll have y prime, and just I put that in front, is 2x e to the x squared. Now you try this one. So if I do y prime here, this is the same thing. The outside is an exponential, the inside is power rule. So I do rewrite it times the derivative of the exponent, and then I rewrite it again, 7e to the 7x. So if you'll notice, just so you'll notice about exponential functions, that if I have y prime is always e to the u times u prime. You're always rewriting it and then times the derivative of the exponent. Alright, let's look at some radicals. So I'm trying to do a little bit of everything. Now here the outside obviously is a radical, and the inside looks like the power rule. So the outside, the only thing is if you have a radical or anything like that, I like to rewrite it to a fractional exponent. So let's rewrite this. Now this is kind of a little bit more obvious. I see the outside now is the power rule, because I'm going to do this, don't touch the baby, and subtract 1, then I'm going to take the derivative of the inside. So the outside is the power rule. Sorry, I touched it. The outside is the power rule, and the inside is going to be the power rule again. So the outside is going to be 1/2, don't touch the baby. We're just doing the mother. And then I'm going to subtract 1, so I say minus 2 over 2, just to refresh your memory. So this is to the negative 1/2, okay? Times the derivative of the baby, which is 6x plus 5. So if I rewrite this, I have 1/2, and then I have 6x plus 5 times 3x squared plus 5x minus 2 raised to the negative 1/2. Another way to rewrite this, you might see, because when you look at the answer key, is it'll look like this. You'll have 6x plus 5 in the numerator. The 1/2, you have a 1, and then the 2 would be down here. And this is actually the square root of 3x squared plus 5x minus 2. But it's in the denominator, so it turns positive. So you can see it either way. How do I prefer it? Well, if you can, I can rewrite it. But this is nice to see this way, because now I say, oh, this is my original function right here, and the derivative actually looks like this. Okay? So let's do this one here. You guys try this on your own, but I'm going to do it here, and you can check and see how well you do. So I'm going to rewrite it. So I see my outside again is the power rule, my inside is the power rule. So 1/2, don't touch the baby, subtract 1, so it's to the negative 1/2, times the derivative of the inside, which is 8. And this one looks a little bit nicer. It's going to be y prime. I can do 1/2 of 8, so it's 4 times 8x minus 5 to the negative 1/2. Or we can bring that down and have it look like this. It'd be 4 over radical 8x minus 5. Okay? Alright, I'm trying to do a little bit of everything, so let's do a fraction now. Again, I look at this, and I'm trying to figure out what am I going to do here. And you can rewrite this as x squared plus x to the fourth to the negative 1. Now the nice thing about the chain rule is before you had to do the quotient rule, here you can do the power rule again. So now I look at this and say, oh, I can do the power rule on the outside, so it'd be negative 1, don't touch the baby, subtract 1, okay, times the derivative of the inside, or the baby, which is 2x plus 4x cubed. Alright, so y prime, you can write this a lot of different ways, but I just kind of brought that in front, 2x plus 4x cubed, and we can bring this down underneath and have it say x squared plus x to the fourth squared. Okay, you try this one. I'm going to rewrite it. Again, sometimes it's better if you shut the tape off and try it yourself, and then you can kind of see if you're getting it instead of just copying down what I'm doing each time. Times the derivative of the inside, which is 1 plus 2x. And so I have y prime is going to be, there's a couple ways to write this, negative 1 plus 2x all over x plus x squared squared, or you can actually carry through that negative either one would be fine, but that's how you do the chain rule on that one. So far we've done exponential, I've done radical, I've done fractions. How about we do exponential and radicals together? So let's look at this one here and say, okay, I've got to do the derivative of this. I have a radical, so I'm going to rewrite it, and I'm going to make this x over 7 be more vertical. I like it better that way, and we're going to raise this to the 1/2. So when I do the derivative of this, I see the outside is the power rule. I'm going to do a half, don't touch the baby and drop it, and then I'm going to take the derivative of the inside, which is going to have an exponential function in there. So let's do it. So I got 1/2. Okay, bring it down front, don't touch the baby, to the negative 1/2. And then we're going to take times the derivative of the inside, and the derivative of the inside is going to be e to the negative x over 7, because you just rewrite it. But then I say, wait a minute, this is my outside, the whole thing, and then this is my inside, and I see the derivative of this is rewriting it, and the derivative of 5 is 0, so that's not even an issue. But now I've got this, because I rewrote it, but this is there. I haven't taken the derivative. And that is the same thing as saying negative 1/7 x. So this is kind of like a bracelet, if you will. We're going to multiply this by negative 1/7, because if I take the derivative of negative 1/7 x, it's negative 1/7. So let's kind of go through this again. Ready? I take the derivative of the outside, don't touch the baby. Then I take the derivative of the inside, which is rewrite the exponential function, and then we have to do the power as another inside. So this is kind of like a bracelet. You do the chain rule 3 times. Okay, it's like a bracelet. So if I were to look at this and finish this up, I have y prime equals the 1/2 times the negative 1/7 I can put together here. So I have negative 1 over 14, and then I've got e to the negative x over 7, so I'm using this right here, okay? And then I can either write that underneath, or I can write it afterwards. So let's write it afterwards first. So I have e to the negative x over 7 plus 5 to the negative 1/2. Another way you can see this written would look like this, okay? This would stay in the numerator, e to the negative x over 7. The denominator, I'll have a negative here, the 14, because of 1 over 14, so the 14's down here. And then this is the radical, e to the negative x over 7 plus 5. So you could see it that way also. All right. Now you try this one over here. So I'm going to rewrite it. So when I do y prime, it's going to be 1/2. Don't touch the baby, to the negative 1/2, because I subtract 1, that's a power rule, times the derivative of the inside is e to the x. And before you never really thought of it, but if you were doing the chain rule, you'd say, well, I rewrite it, and if I took the derivative of x, it'd be 1, but you just never had to do that. So you can stop. It doesn't have to be done 3 times. Sorry. It doesn't have to be 3 times like before. So I would rewrite this as y prime is, let's go right straight to this, e to the x would be in the numerator. I'd have a 2 down here because of the 1/2, and this would be, whoops, the square root of e to the x plus 1. Okay? Let's practice a few more. Here's 13. So I have exponential with a radical in it. So we're going to rewrite this so it looks like this. So I have e to the 4t, and that's raised to the half. Already you can see where the chain rule is going to be. So let's do y prime. Okay? So y prime is, you rewrite it, so I'm going to rewrite it the original form. Okay? So that's the outside. Then I have to take the derivative of the inside, and the inside is going to be, I actually have 2 more to do, because I'm going to take this whole derivative, and then I'm going to take the derivative of the inside, which is now the 4t. So we have like 3. So I'm going to rewrite the outside. The derivative of parentheses of 4t raised to the half is 1/2. Don't touch the inside, or the baby, to the negative 1/2. And then I got to take the derivative of 4t, which is times 4. So this has got 3 pieces to it. So if I look at how I'm going to rewrite this, I can do the half of 4. So I have y prime equals 2 e to the radical 4t times 4t to the negative 1/2. Okay? Or you can see it written this way. Y prime is 2 e to the radical 4t all over the square root of 4t. Okay? Now you try this one. This one I don't have to rewrite. So I can say y prime is, just rewrite it, e to the x cubed times the derivative of this one would be 3x squared, which is power rule, and I just write it up front. 3x squared e to the x cubed. That one's a little bit easier. Okay? Now we have some trig functions mixed in. So I had to warm you up to get to the trig functions. So let's look at this one in another video. So I'm trying to break this up a little bit for you.